Okay, are you able to see my screen?
Yes, slightly.
Okay,
Yeah. Yes.
introducing OpenShift software-defined networking. Okay, before that, let me ask you a question. Have you completed the all the labs till fourth chapter?
No, I have today started the third. I have completed the third chapter. So in the night, I will complete the fourth chapter.
Nagi?
Yeah, I have to start. I will start for the by this week. I will complete all of the labs today. This week, end
Okay.
of this week.
Okay. Introducing OpenShift software-defined networking. Okay, so there is the concept of SDN. Basically, only a theoretical explanation is given in this chapter because SDN is a very big topic. Okay, but yeah, SDN is something like a programmatic approach. Okay, to achieve the flat pod network. Okay, over the worker nodes inside a cluster. Clear? Now, let me make you understand with a very simple example. Let's say you have this physical machine and you have this physical machine. Let's say you have four physical machines. Clear? Now, if you want to make these four machines in a same network, what you will do? Manish or Nagi? I want this four machines in a same network. How will you configure that?
Same subnet we have to provide.
Do we need a router?
Yes. No.
Hmm?
If it is different network, then we need a router. Yes.
Okay. Let's say I have almost 32 physical machines like this. If I want to connect them in a same network, what components I need? Do I need a router switch?
Yes, absolutely.
Yes.
Which
We
is
need a
needed?
switch if the all the 32 physical machine will be the same subnet.
Same subnet.
Yeah, I want these 32 physical machines in the same network. So I will connect all the LAN cables from these 32 machines to a switch, right?
Correct.
Yes.
And I'll provide that particular one cable from the switch to a router, right?
If it is different network, then we can use router, right?
No,
Okay.
I want them in the same network. Okay, I want them to
Yes,
be
in that case,
having the
yes, in
IP
that
address
case,
from a router,
every
DHCP server.
right. In that case, everything will be connected to the switch, and all they are connected to each other and communicate each other. The same
Yeah.
subnet. Yes.
Okay.
So router or some DHCP server which is running on the router is responsible to assign the IP addresses to all the physical machines. Okay, but I have connected them with the switch. Clear? Now let's say on that particular switch, let's say you want four different networks. Then how you can configure that? Can you configure it with VLAN?
Correct. Absolutely.
Correct. We can configure that with VLAN. Okay, I'll like create like four slots of eight at like sockets, and I'll provide them the VLAN. Okay, then whenever any packet will be coming from that particular set of eight slots, then that particular packet will be having some VLAN ID, and accordingly I can isolate them. Right
Yes.
now, now that is okay. Now let's say on this 32 physical machines, you want to run your pods. Obviously, whenever you deploy anything on a Kubernetes, let's say you want 32 replicas, or let's say you want 10 replicas. Kubernetes or OpenShift can deploy these 10 replicas on any of the machine on 32 physical machines, right? And I want these all the pods in the same network. So can I configure a virtual router over here? Yes or no? Can you achieve, like, can you create a flat pod network between all the pods which are running on all the 32 physical machines? How can you do that without a router, without a switch, without the concepts of VLAN? How will you isolate them if they are into two different namespaces? So you will always needing a virtual router or a virtual switch inside it. Okay. And SDN is all about that. SDN is something like a programmatic approach to give a flat pod network over the cluster. Now in Docker, it is not possible. Connect two containers directly on two different hosts. Okay? You need to go for some overlay network. That is something like SDN. Now for SDN, we do not need to go any deep over here. Okay. But yeah, let me tell you some softwares which are available to give you this SDN facility. The number one is Flannel, which is quite famous in the market. Number two, which is Open vSwitch. These are the softwares which can provide you SDN facilities. Okay. So instead of having the physical router or the physical switch, these particular softwares are that much intelligent that they can create virtual switches over the worker nodes inside a cluster, and they can create a flat pod network. Okay. All the pods which are running on different worker machines, they will get the IP address from the same network. Now, though you can also change that. Number three, you have Cilium. Number four, you have Multus. OpenShift 3.9 were on Open vSwitch. Right now, the OpenShift 4.2 is on the Multus. Clear? And many more you have. Very famous, which we use in Kubernetes, that is Veeam. Clear?
Excuse.
So, software-defined networking is a networking model that allows you to manage network services, like through the abstraction of several networking layers, and it decouples the software that handles the traffic called the control plane. Control plane is something like your master node, and the underlying mechanism that route the traffic called the data plane, which is your worker nodes. So, in OpenShift Container Platform, the SDN solves the following 5 requirements. Managing the network traffic and network resources programmatically. So the organization teams can decide how to expose their application. Managing communication between containers that run in the same project. Okay. Let's say you have created one project now. OpenShift will automatically apply a VLAN ID on that particular project. Okay. And let's say in that particular project, you have 5 pods. Okay. And that the VLAN ID of that particular project, which is having that 5 pods, is 5. So whenever any packet which is going from that particular project from that particular port, that will be having the VLAN ID is 5. Okay, and it can directly communicate to the pod which is having the same VLAN ID, which is 5. Okay. So the concept which we were using on the switch on the physical hardware as a VLAN, right now we are using on the project. Managing communication between pods, whether they belong to a same project or run in separate project. Managing network communication from a pod to a service. Managing network communication from an external network to a service, or from containers to external network. Everything is managed by the SDN in a programmatic manner. Now, and one more thing, on these all the worker nodes, one pod of Weave, let's say I'm taking a software example of Weave, one pod of Weave will be there. Okay. Even on the master node also, you will be having the one pod which is running for Weave. That particular pod is actually having a virtual router that is responsible to assign IP addresses to the pods which are running on this particular node. Let me give you an example over here. kubectl get all -o white -n cube system. See, this particular Weave pod is running on node 2 also. Weave pod is running on master also. Weave pod is running on node 1 also. Okay. So this particular Weave pod, which is actually giving you the facility for SDN, is responsible to assign IP addresses to all the pods which are running on node2.kushal.com. So on every node, you will be having a Weave net. Like that in the OpenShift, you have Multus, right? Right now, OpenShift 4.2 is or 4.x is using a software of SDN as Multus. Clear?
Question I'm audible.
Yeah.
Question. So the term you are saying that the assigning an IP is
Yes.
taken care by Weave, right?
Yes.
So, because as per my understanding or normal as a Linux understanding, so this functionality will be done by a DSCP agent.
Yes. Yes.
So Weave is also a same thing like a
Weave is
DSCP,
having a virtual router actually.
like a OVS, right?
No, OpenV switch is also same as Weave actually.
Basically, OpenSwitch is a is a switch to process is a logical switch which process the packets on the
Same
Linux
network.
part, right?
Hmm.
So when you say that assigning an IP is a Weave, then I'm not understand. This is a very confusing statement.
Kushal, can you
Two containers inside it. Okay.
explain
Yeah, and that two
the
containers
physical
may be
switch as well as
responsible
the
to assign the
software
IP
defined?
addresses to the this particular, or maybe they can have the OVS. Clear?
No, sorry. Can
Just
you
a
please?
second. Let me give you
Okay.
So I'm not a guy who have a very good expertise in the SDN, okay, but that is just a part, like a very
No
basic.
problem. No problem. No problem. No problem.
Yeah, but we can try to find out. These two containers are there, okay. Weave init is there and Weave is there, okay, and it is also having a range, I think, over here. Some range is given. Just a second. The range is not given over here, okay.
No, just go to that upper show port list of ports. What you're saying where we have the list of ports. I think you are seeing in the we will find in the master node. I think you are seeing the worker node described maybe.
No. 3 pods are there, okay. See, these are the pods which are right now available.
Can you please describe
Master
this?
also you have this Weave pod.
Right. Can you please describe this one?
There will be no changes because these Weave net is actually controlled by a daemon set, na. This daemon set has created 3 replicas. So they are same actually. There is no difference between them. Okay.
Okay.
कुशल एक आर्किटेक्ट डायग्राम से आप बता सकते हो फिजिकल नेटवर्क और ये जो अपना वर्कर नोड और मास्टर नोड और फिर बाद में पॉड में कैसे वो अपना फिजिकल नेटवर्क विद एसडीएन कैसे वर्क करता है?
Now say what you are saying.
कुशल जो आपका एसडीएन है तो वो ने क्या जो फिजिकल मेरा स्विच है स्विच के बाद में क्या सर्वर को कनेक्शन आता है सर्वर टू फिर बाद में क्या एसडीएन को आता है
actually a core part of SDN Ashish actually. Complete core part of the SDN, okay.
Okay. वो एक बार अगर डायग्राम से अगर आर्किटेक्ट डायग्राम नहीं है क्या यहाँ पर
I can tell you that no. I can tell you that how the traffic will come on the worker node and how that particular traffic will be processed from the service to the pod. That I can tell you. But at the backend level, how SDN is actually creating that virtual switches and all the things, That I also don't have any idea.
Okay.
Okay, because it takes only one command to set up this way. Okay.
Okay, understand. So, Kaushal, let's complete this theoretical part. Then I feel we can discuss this part. If whatever the use cases or whatever the doubts we have.
Especially
Okay.
this particular topic, SDN. Like say if I want to like set up a Veeam network, just this command I need to run, and in the back
Understand.
end it set up everything. Okay.
But this is a very important topic because normally in production we are stuck. Everyone stuck is here.
तो आईपी एड्रेस रेंज अपन दे सकते क्या डिफाइन कर सकते हैं
Yeah, that
ऊपर
you can define. Okay, while
That is
installing like in
Ashish,
Kubectl
yes, while
also we decide
correct.
the IP addresses range. Okay.
In OpenShift, while doing the planning, we can set a private range, whatever we want to set. So that we can set while during the installation of the OpenShift.
Yes, and for that you can find the necessary information on the documentation.
There is
Configure.
Yes, yeah, there is one environment file we need to prepare before starting the installation. So in that part, you have to mention that exactly a public network called or something another network. So you have to mention that particular range.
Maybe it can be.
Yes.
Using the Multus CNI in OpenShift.
No, Multus CNI will come in picture only when you need a segregation of the traffic on the different interfaces. So how to segregate that part? So this in that scenario, Multus will come in picture. In the normal just a POC setup, there is no Multus required in that scenario. Only one NIC is there. Then normal SDN will. Normal networking will enough to handle these things.
Or over the pod level.
Correct. But in a scenario where you have a 3 pod is running on the or multiple pod is running on the one physical server, so you want to segregate it to send the traffic on the different physical switch as well, physical NIC as well. So in that scenario, the Multus or these things are come in picture, and a lot of things need to be done on the configuration level.
Okay.
Yes.
Okay. You might be having a good idea about the SDN, Manish.
No, I'm trying to learn this part, but very limited opportunity to get this to understand that. Let's complete first and discuss, read this all the critical part, then we will ask some queries.
Yeah. So migrating legacy applications, they have given you a diagram how all pods are connected to a shared network actually. Okay, see. Project 1, Project 2, Project 1, 3, 2, 1. These all the applications are running over here and they are get the IP addresses like this 10.128. Okay. Now they all are in the same range. Okay. So there is a Kubernetes pod SDN and the range for that is 10.128.0.0/14. Okay. So all the pods which are running on all the projects inside every node, they will get the IP addresses from this network range. Now like this, you have the SDN for the service also. Two SDNs are generally there. One is the pod SDN, one is the service SDN. Okay. Service SDN pod will be responsible to assign IP addresses to all the services. Okay. Which actually do the work of load balancing. One more thing I have an idea about over here, which is not present in the book, that generally you have 3 policies over here. Okay. One is OVS subnet, one is OVS multi-tenant, and one is OVS network policy. If you are while installing OpenShift, okay, when we I was installing OpenShift 3.9, we were having the option to change this policy in the master configuration file. Okay, right now in 4.2 also we will be having some option. If the network policy is OVS subnet, then it means that all the pods from all the projects can communicate to each other. all the projects inside the OpenShift will be having the VLAN ID as 0. So all the projects pods can communicate to each other. In multi-tenant, VLAN will be different. So no project can communicate, no pods from the different project can communicate to each other. Clear? In OVS network policy, you can define your ingress rules. Okay. That, let's say you are working in a project A, or let's say you have project B. Now inside project A, you need to create a resource like network policy. And you can define some rules over here that accept the traffic from the pods or from the project B. Okay. So like this, you need to create this resource, like the way we create secrets in a project or in a namespace. You need to create this network policy resource. So these three, I think different types are there: subnet, multi-tenant, network policy. Okay. Now, using services to access pods. Now see what exactly the service is. Let me tell you. Let's say these are 2 worker nodes. Or let's say these are 3 worker nodes. Okay. And you have deployed an application and you have given the replicas is equal to, let's say, 6. Okay. And you are deploying a Apache application. Now, this particular worker node is having the IP addresses is 1.1.1.1. This is having 2.2.2.2 and this is having 3.3.3.3. Let's say scheduler has scheduled 2 pods over here. Okay. Scheduler has schedules 2 pods over here. And scheduler has scheduled 2 pods over here. Total 6 replicas you are having. Now, obviously, customer always wants to see the website. How the traffic will be going to these pods. Now, how you will do the load balancing between all the pods which are running on different worker nodes. So for that, you have a virtual concept. Service is something like which is a resource of OpenShift or Kubernetes, but it does not run inside a pod. Okay, it is just a virtual program. Okay, or a virtual rule. So you will always be creating a service. That service has a capacity to listen on all the worker nodes. And now there are different type of services. Let's say you are creating a service type of node port. So when you will be creating a type of a service as node port, the service will open a port number on the worker node. Let's say it has opened 32,000. So same port will be opened on all the worker nodes. Okay. Now let's say you are having a load balancer over here. And that particular load balancer has 3 rules to send the traffic on 1.1.1 32,000, 2.2.2.2 32,000 and 3.3.3.3 32,000. Clear? So it can divide, it can send the request to these particular IP addresses. Okay. Whenever any request which is coming on the 32,000 port number of this IP, the service is listening on it actually. Okay. Once the service gets the details, what service will do? Service will forward that traffic to all the pods which are running inside the cluster. Clear? Now, how the service knows about where to forward the traffic, which are the pods, then that is generally done by the concept of selector. Let's say you have given the selector as here app colon nginx. Okay. And let's say you have the same particular label which is applied on all the pods in the application. Okay. The service has the idea about what pods are available in the cluster which are having the label as app colon nginx. And accordingly, this particular service will get all the endpoints. Endpoint means IP of pods. Okay. And it will automatically forward the traffic to all the pods inside a cluster. So this is something like an example of the service which is of type node port. Okay. And generally the range of the node port is 30,000, I think 30,000 to 32,767. I think that is the range. Okay, we can confirm that. Clear? So service is not not running inside a pod. It is just a virtual thing. Okay. So whenever you are creating a service of node port, it will always open a port number on the worker node. Okay. And whenever some traffic which is coming on that IP address on port number 32,000, that particular request will be handled by service. And the service will forward the traffic on all the pods. Okay. How the service will know about all the pods? Service will use a selector. Okay. To identify the pods which are running the application Nginx. Clear? So this is the one type of service. Another type of the service is cluster IP. If you are creating a cluster IP service, means the service will get an IP address. In the node port also the service will get the IP address, but in the case of node port, one port will be opened on the worker node. But in the case of cluster IP, the port number will not be opened on the worker node. The service can only be accessible from inside the cluster, not from outside the cluster. Okay. So for that, you have the service SDN which do the work to provide IP addresses to the services. So that is the concept of the service. Clear? So that is the service. Now let me give you an example also. Let's say I have created a namespace and kubectl. Let me create a pod.yaml. Let's say this is my pod. I'm running a normal container inside it, which is Nginx. Clear? Namespace is grass. Let me do one thing. Let me create a deployment because I cannot give a replica in a pod YAML. Yeah, that would be fine. Replica is 6. kubectl create deploy.yaml -f. Namespace grass. And kubectl get all -n grass -oy. Now application has been deployed, but how will you access that? While you are on the master node, you can curl each and every pod, but I need to do load balance now between all the pods which are running on node 1, node 2. So I need to create a service. Now to create a service Kubernetes. This is the link. Let's say you want to create a node port service. This is the example. Let me copy this. Let me paste it over here. Vim service.yaml. Let's say you want to open this 30,007. Target port is 80. It means that the service will always forward the traffic on the pod IP address on port number 80. So this is the pod port number. Okay. This port is the service port number. And this is the worker node port number. Clear?
Service, just hold on. Port 80, first port 80 is basically
Port number of the
service port.
service.
Port of the service, right? Target port is service port of, sorry, port of pod. What it mean?
Yes.
What it mean?
Pod
Go to the
port.
diagram,
In the
whatever you're showing on the paint.
your pod gets an IP address. Huh?
Correct.
So that is the port number 80.
So whatever we deployed the pod or container, we have given the 80 number port in that.
Yeah, it will always send the traffic on the pod IP address on port number 80. Okay.
So in that scenario, we have this what we have learned in during Kubernetes lecture. So we have to disable the 80 port on the by default on the worker, correct? Because by default
correct or no?
No, why you need to disable the port number on the worker?
Just okay. Let me ask again.
Manish, NGX using the 80 ports on pod and 30,007 is using on worker.
We need to send the traffic on the worker node on port number 30,007, Manish. That is the first requirement.
Okay.
They need port forwarding to 80 port on the pod.
For that, we can configure a network load balancer. No, the customer is requesting on this particular network load balancer on port number 80, and that network load balancer is going to like send the traffic on these 3 IPs on 32,000 port number, right?
Got it. Now got it.
Just a second, guys. Hello. Kakroli hu main na. Now, app colon nginx. Okay, this selector is very important. You always need to give the selector which is actually matching some label on the port. Service name, and we need to define the namespace also. That's it. Now, kubectl create -f service.yaml. Now see, service has been created. Now service is having the cluster IP, means it is a type of cluster IP service, but it is also a type of node pod. Clear? You cannot create a service without an IP address. So service is always a type of cluster IP, but it is also a type of node port also. Clear? Now, 80 port number on which the service is listening means you can directly curl on the service IP address 10.100.172.34:80. You can curl this. It will give you the reply. Nginx. It is doing load balancing.
What is the pod IP?
Yeah, just give me a second. Let me give you a very good practical over here. I'm going inside all the pods and I'm changing something over here. Echo reply 1. Let me change a little bit. See, it is giving you, it is doing load balancer. One is welcome to Nginx, second is reply 1, third is reply 2. kubectl get all -n grass -o.
No, but we have changed in the two pod, right?
Yeah, I was just trying to tell you that it is actually doing load balancing. Clear?
Okay, so if you tried 10 times, maybe 5 or 6 times, it will show the reply, but otherwise give the different output, right?
Yes. One from one pod, one from second pod, like this. Now see,
Okay.
right now you are directly curled, or like you are directly connecting to this service IP address. Now
So
this, see,
this cluster IP called as a service IP, and it will be seated on the load balancer services, right? Or load balancer node.
yeah, you cannot access this IP from outside the cluster. For that, what we have configured? We have configured the node port. This port has been opened on the worker node. Clear? Now, what can I do over here? kubectl get
But who
nodes.
will, let's suppose, take an example that one website is running as a web server. Just hold on. I'm sorry, I'm saying, Kushal, let's suppose one web server is running, right? Matlab five or six web server is running as a front web server. So the request is coming on 80 port, and the URL or URL IP or IP is 5.5.5, correct?
Yes.
So in that scenario, the service IP should be different, right? That should be taken from our what are the range we have selected in our configuration, correct?
Yes. Yes.
So that IP, how the netting will happen? So the netting will be done by the external load balancer, that netting?
Netting, network address translation.
Yes. Let me example. Okay.
Obviously, if some packet which is actually going from this particular IP to network load balancer, then network load balancer is responsible to do the netting.
Correct. So I have to give that my load balancer service IP, that what we say 10 dot. Can you go to this?
No. You do not need to give your network load balancer a service IP. The service is also listening on the node port now on 32,000. See, right now, see Manish.
I think you understand.
Addresses of my
You
two
are
worker nodes, right?
Correct.
These are public IPs.
Okay.
Yes. I can directly copy this IP and make a request on this IP on 30,007. Let me do that. 30,007. See, it is giving you reply. So whenever I am hitting my worker node IP address on 30,007, who is listening there? Service?
No, Kaushal, I understand, but this IP is not published or published to the external world, right? This is not a direct word in a normal production scenario.
This is the public IP now. I can right now create a network load balancer who can forward this request on this particular IP address on 30,007. What is the problem? This is the public IP of my worker node. You can also access this website. You can try to hit this IP.
Understand that because you have this is your setup as a testing setup, and you're running on the AWS cloud. That's why you are saying that this is my one VM is running on that public IP. You just access that whatever the pod is running, you will do access. That is fine. I'm virtualizing that in the scenario where let's suppose one website is running as Amazon, correct?
Yes.
So its IP is its URL is www.amazon.in, right? But its IP is 5.5.5, right?
Okay.
So whenever any user want to access that 5.5, correct?
Yes.
The request is come on my external gateway, correct?
External load balancer over here.
External load balancer. Okay.
Yes.
So these 5.5 request by default routed to the my pod, basically.
Not pod, worker node IP address.
So that's why, okay. So you are correctly. So where you have mentioned that NLB, what is that?
Network load balancer.
So this is the external load balancer, right?
Yes.
Okay. So these load balancer, okay. So we will configure this extra in the configuration of the external load balancer. So I will do some configuration that that my traffic is coming from 5.5.80 should be sent to the port with the port number 32000. Is it?
On worker node IP address.
So I need to do the entry for all the worker node. Is it?
Yes. No,
Means
even see, that is not needed.
Kushal, can
Even
you
if you are
add
not doing this entry, na, that is also okay.
Kushal, can you add 80 port on the port so Manish can understand?
What you're saying?
80 port in the pod. Yes, so Manish,
80 port over here,
8
node port.
no, in pod.
No,
in,
that is clear, Ashish. That is clear. That understood.
Okay.
So
Yeah, the
but
pods are working on 80 port now.
that is fine. That is fine.
The
So-
containers are listening on 80 port number.
So my question is, Kaushal, so manually or anyhow we need to do the entry of all the worker nodes in the external load balancer. Is it?
Not all the
Can-
worker node addresses. You can even enter one only.
What enter my why? What I'm not understand. Enter one.
Only one IP address. See, when the customer will hit www.amazon.com, that request will coming on 5.5.5.5:80, right?
Okay.
After that, you have done the entry of 1.1.1.1:32,000 means it will always forward the request on 32,000 port number on 1.1.1.1, right? Yes, till here clear?
Just hold on. Just hold on. So where that
See,
this
this
mapping
external
has been,
load balancer is hitting this particular worker node IP address on 32,000, right?
so right. So you are saying that we have to or external load balancer admin has to do the entry of 5.5.5.80 to map to the 1.1.1.3820.
Yes, that is needed.
Okay, that is needed. Fine. So
Yes.
how? So okay. So how to route the traffic on the 2.2.2./32,000?
Yeah, let me tell you that.
Hmm.
Yeah. See, once the request has been reached to this IP address, okay,
Got it.
this will be taken by service.
Okay.
Okay. Now the service has the capacity, okay, to forward the traffic on all the worker nodes because all the pods are in the same network now.
So this service is running on the full pod level, is it? I am audible. I am lost, Kaushal.
yes. Yes.
Okay, I think I lost Kaushal. Kaushal, you are lost.
Hello.
Now audible. Now you are audible.
So once service has taken the
Sorry.
request, service
I
will
have-
try the selector to get the IP addresses of all the pods, right?
So this service things are running on the top of the worker node, not inside the worker node, is it? Or it's
Yeah,
running
it
on
is
the
just
or
a
the-
virtual rule. It is not
Correct.
running as a pod.
right. So it should run on the master node or as a infra node of the as a controller node, right? Who will managing
Yeah,
all
even
these
you can
policies.
see here. This service, it will not give you any IP addresses over here. Okay.
Okay.
Here, this is just a virtual rule we have created. So if the
Understand.
request
So-
is coming on this IP address, the service will be listening on it. Once the request has been reached to service, what service will do?
Okay. So basically this is the service we can call it as a load balancer or router services which provided by the OpenShift as a
Kubernetes.
in Kubernetes or in OpenShift we called as a router service is an inbuilt service by the providing by the OpenShift.
Yeah, Kubernetes has provided you this inbuilt service. Okay.
Correct. So that will taken care of these parts to maintain this traffic routing or load balancing everything. Right?
Yeah, everything. Now this particular service, on the basis of selector, firstly it will get the IP addresses of all the pods. Okay.
So
Now,
we have to
obviously
do
it has a
so.
selector.
so one in the initially, so we need to do the entry of 1.1.1 on 3200 on the external load balancer first
Yes,
time.
that is
After
needed.
that, automatically the service feature will take care of this all the load balancing of the traffic,
Yes,
right?
yes. Even
Okay.
see, you can get kubectl get EP hyphen and grass. EP means endpoints. The service is having the endpoints of all the pods, right?
I understand that. I think.
And this is the port number 80.
So this is the endpoints of the below are the IPs of the
Pods.
pod IP, right?
Yes.
So under the service IP, that is 10 dot whatever the IP is, under that all these pod IPs are associated with that, right?
How the service is knowing about all the pods IP addresses? With the help
Can
of
we can
selector.
come again the last line with the
How
selector
the
method?
service is aware about all these endpoints?
Correct, on the basis of the selector, right?
Yes.
Right. So so can we is there any default policy that the traffic is routed as a round robin, or we can set a percentage that this particular
That is also possible, but that is not possible in the layer 4 network load balancer. For that, you need to configure application load balancer. And right now, this is the approach which I'm telling you. I'm just trying to make you understand service concept. This is not the approach which
Just
we use in production environment. Clear?
okay, got it.
That I will tell you with a very good diagram. Okay, that how in the production you can maintain your website on a Kubernetes cluster. Okay.
But the telco world scenario is very different from the IT. So we need a very different things in telco world.
Okay, we will try to discuss on that also.
Correct.
But are you clear about the service concept, Ashish, Nagi?
Yes, Kushal.
Okay. So see, they have given you the example target port, protocol, HTTP, service name, label, selectors. So one is a cluster IP of type.
Kaushal, so in paper, so these all the YAMLs we will get it, or we need to remember all the YAML file as well?
No, you can directly create a service with the command actually. In the exam, you do not need to create a service. Everything will be created.
Normally, whatever we copying the YAML file and creating the service or these things. So these things need to be created by us, or by default references will be given in the examination.
No. In the exam, no reference is given. In Kubernetes exam, you have complete access to the documentation. Okay, but in OpenShift exam, you do not have these type of questions. Clear?
Okay.
Everything will be created there. You just need to troubleshoot. Clear?
Okay.
That is
Let's
actually a
discuss
tough
that.
part. To create thing is easy, but to troubleshoot the thing is difficult. Okay.
Okay.
Okay. So I think from here we can continue tomorrow, guys. Okay.
Okay. No problem. That's good.
Okay.
Tomorrow I'll like finish here. Okay.
Let me share one screen for you guys. Just hold on. Can you stop the recording?
Yeah, just a second. Recording is stopped.